The next session will be Pascal Menezes, who will talk about the work that Microsoft is doing on the Lync API. And when the demo guys get back, we will turn that back to the demo to show you the integration itself.
Okay, thanks. Well, I'd like to thank everybody, and I'd specifically like to thank Aruba for having us here. Aruba is an awesome partner. I've been involved with Aruba from day one, working with their great team, and we have nothing but success with Aruba, nothing but great things. So let me start a little bit about what we're trying to do here. And where's the, let's see, okay, here we go. So myself, Pascal Menezes, I was tasked to go figure out how to make Lync work over Wi-Fi. And I know it seems kind of like, well, that seems pretty straightforward. But, you know, a few years ago when we looked at this, or 2+ years, it seemed, it should work. But after actually going through this, and Aruba was a very key partner in helping us navigate through this, we found some very interesting things that certainly for IM and present, it works flawlessly for data. But when you come to voice and video, oh my God, it was riddled with all kinds of issues. And slowly we debunked all of that together with Aruba, and we've done some great innovation and we've moved the ball rapidly forward, and I think we're getting some great experiences now. So I also own a bunch of other things. I also am driving the SDN strategy, and then I also chair some other groups. One of the interesting ones I'll come to is this group that we've worked together, Aruba and ourselves, started this to go drive this mobility story. And I just seen some examples of some technology that Aruba's come up with. We're actually driving this to a standard model so that we can do this for any BYOD device. So I'll cover that later. So I'll cover a little bit about Lync. What is Lync? And then I'll cover basically, you know, what's this program we have, this Wi-Fi Lync partner program. And then finally, we'll cover some trials. What did we learn on these trials, the 2 years we went through this inside Microsoft? And finally, this API that Kriti talked about is this very cool API that enables very, very cool scenarios. So I believe I'll go through this and we can do a Q&A after, but if something comes up, please feel free to interject. So what is Lync? How many people here know about Lync? About half the room. Okay, so let me kind of go through that. So basically, when you think about it, the old days of communicating was a handset, like Kriti talked about, plugged into the wall. In the past, it was TDM. Then we went to VoIP, and that was really the extent of that. And then you'd have these different silos. You'd have a video conferencing in the room, and then all of a sudden you'd have email, and then they had all these different silos of how you kind of communicated and collaborated. And what Lync's done is we've taken all these different silos and brought them together. So instant message, we came out through instant messaging and IM and presence. That was our kind of Trojan horse into everything. And from there, we kind of grew out all these different modalities of communicating, from audio conferencing to web conferencing to video conferencing to all these various modes of how you communicate. And then also in the Office applications, all applications, you don't have to do nothing. You can see a name of an email, you right-click, and you can talk to them, IM, you can video conference them, and so on. And so we deliver this through like this enterprise-ready platform that can be rolled out and supports all these modes of communicating. And we have it in a very rich amount of clients, as you'll see in a second. And then finally, a single system to administrate this, very linked into Active Directory and very linked into our whole Microsoft kind of Office suites and other applications that want to use this. So Lync actually is, from a voice point of view, people think Lync, oh, well, you're that IM and presence kind of presence guy. But not really. We've actually done, since Lync 2010, we've enabled enterprise-grade quality voice. And since then, we've had some great success in rollouts. As you can see, 70% of Fortune 500s are using Lync, 250% growth rates in voice users. And then 86% of all U.S. enterprises who trial Lync start to deploy Lync. And it's really cool because the Lync client Office 13 is shipped in there. As you'll see, we're going to be federated with Skype. We are federated Skype in 2013. So some really great features. You can see very large deployments of voice. And so my point is we are voice, ready, enterprise ready, mission critical ready. So the other thing I want to talk about is that in Lync 2013, we just released that, I believe, in around February or so. We have new features, multi-party HD video height, HD video conferencing. You can see multiple parties. It's adaptive. It's got H.264 SVC, so standard-based codecs. Also, we have a very, very rich platform of mobile clients, and this alludes to Wi-Fi. This whole enablement of these rich clients running on BYOD devices and all these these new tablets and all that is enable a whole new way of communicating to be mobile. So mobility is the key scenario. And finally, obviously, Office integration. Anywhere in an Office app, you see something, you want to call them, IM, text them, video conference, all there, right-click. And then federation with Skype is very cool. We are under the Skype division. Lync and Skype is now one division. So Lync is the enterprise version of the Skype. Skype's the consumer version. And we are one division. And now we have federation in 2013 between Skype and Lync. So a Skype client can talk to a Lync client, and you can do IM and presence, and you can do audio calls and so on. So it's a very cool. I mean, it gives us a huge amount of, from the enterprise, you can call home, you can talk to your wife, you can talk to any other Skype user, all from within the Lync and vice versa. So this is very, very good. As you can see, our mobile clients, we have a large now, almost every platform, every iOS, Android, our own Windows phones, so on. We have a very rich set of features for very rich sets of operating systems, tablets, smartphones, and so on. So this starts the whole world of I want to be mobile. I want to have and take with me wherever I go my form of communication. I'm not tethered to the desk anymore where my phone is, or my desktop. I got my laptop, I got my tablet, I got my smartphone. Wherever I go, I'm connected to all my modes of communication. And whether I'm on my desk or I'm across the lobby, all of my devices ring, or I get IM messages or whatever, and wherever I am on whatever device, I can respond to this. So this has actually enabled a great scenario for users that they see a lot of value, that they're always connected. So a little bit about the Lync Wi-Fi Partner Program. A few years ago, we struggled. We knew this was coming. This world of being mobile and be able to move and use any kind of these BYOD devices to run your UC application. And so we kind of struggled, well, how do we make sure voice and video runs correctly on that? How do we preserve that end user experience? And that's very critical to us because we care about that. That experience is everything for us. And when we looked under the covers, we saw it was riddled full of issues. And thanks to Aruba, who was what we call a depth partner, we actually worked with one or two strategic partners to go kind of uncover and figure this out. And Aruba was one of them. Actually, the only one in the Wi-Fi that actually worked with us, and helped us figure this out. So we're very grateful, great partnership with Aruba. So the whole idea was a better together story, and I'll talk about what that means. So when a customer buys Lync, they want to make sure that they don't have to go figure out how to turn the knobs and how to deploy Lync on Wi-Fi. So that's what we do in partner engineering. My job in partner engineering is they buy something, how do they integrate into the bigger things, whether it be Wi-Fi, or I'm in the networking side, or phones, or session border controllers, and so on. That's what we do as a team. But in this case, for Wi-Fi, how do we make sure the user or a customer buys Lync, gets a great experience over Wi-Fi? So we call this the better together story. We work together to figure it out, and we'll talk more. We also have a qualification program. The qualification program, think of it as a certification program, but our legal doesn't like the word certification. We call it qualification. So qualification means that we've actually done all the testing with them. And we have a very extensive testing methodology and plans and test cases to do that. In fact, in this case of Wi-Fi, We have close to, I believe, 180-page 7 documents and hundreds of test cases to test this. And finally, I'll talk about this new program we've launched out called the API, Network Diagnostic API. It is this forward-looking view to SDN, and it's the same API that we will use to mature into SDN. And more on that, at some future point. As Kriti alluded to, we can do some very interesting scenarios. So I'll cover that. We put the program into 3 categories. And that's Lync over data, which everybody knows how to do. It's IAM and presence. And there are people who just want to use IAM and presence. But the majority, when they talk about real-time media, voice and video, and even data collab to some level, they want to make sure it runs correctly over Wi-Fi. So we broke that out to further 2. Fixed scenarios, meaning you start and end a call pretty well within, the area that you're in this conference room pretty well. And then finally the mobility, the mobile part, you're moving. And this part had, a lot of issues to deal with because, like we talked about, the sticky client. How do you deal with that? And unlike data, which can tolerate a lot of different levels of quality from the Wi-Fi, voice video will not do that, and we'll talk more about that. So in our program, we actually have 2 parts. We have the AP infrastructure part, data only, real-time media fixed, and real-time mobile. We test all 3 of these parts with our lab. And then finally, on the device side, we try to do the same thing. What we find is that this is where things are really broken. The BYOD devices, all these devices that are not kind of given out by the corporation, even some of them are riddled and with a lot of driver issues, a lot of problems, the sticky problem being very, very critical. And I'll go about the kind of 3 problems we found out in our dog foods, in our trials in Microsoft to figure all this out with Aruba. So I like to say that Aruba is qualified as in the AP infrastructure side. They passed all 3 of the data only, the fixed, and the mobile for voice video. And these are the devices that they're qualified. Obviously, Dell, I think everybody knows Dell is OEMing. Yeah, so I think that's public, right?
Yeah.
Okay. Okay. So, and you can find the link of the qualified partners on there. Today it's Aruba and Dell, and this is what you'll see on the website. So, and over time we'll add some more. So the Microsoft Lync Wi-Fi qualification program uses Ixia. I don't know if everybody knows Ixia, a really high, world-class test and measurement company. They have a state-of-the-art labs. They use Faraday cages. They have automated equipment. So right here in Santa Clara, they do the testing, and they qualified Aruba, and they'll continue to qualify other partners. So, so that's really who does all our testing for us. And so basically, I'm going to go into the 2 years of what we did at Microsoft to kind of make all this happen. The qualification program came after the 2 years of all the things we figured out, all the kind of big alligators we had to chop down to make kind of the experience work between Lync over Wi-Fi. So like I talked about, the 2 scenarios before was the first one is the fixed running voice and video. Very common. We'd go in a conference room. We would plug, you had to plug into Ethernet in the past, and that's what MSIT said, Microsoft IT said, in order to run Lync, you must plug into Ethernet. And it was like, are you kidding me? We have a laptop. Why am I going to be fixed into an Ethernet? And, it's crazy. We walk in a boardroom, we flip up a laptop, we want to go. And so making, Lync work over in, where we get together, especially in the conference rooms, and running on Wi-Fi was a big deal. And sometimes when you had tons of people, it was a problem making voice and video run. Obviously, that was the critical one because we were doing voice calls, voice conference calls, and so on. The next one was basically with the advent of our release now with the smartphones, which I left on the table, very common, I'll get a call come in, and I'm at my desk, and I'll pick it up. I'm ready to go to a meeting. I'll pick it up, and I'll answer the call. Instead of answering on my desktop or on my fixed desktop, I'll answer it on my smartphone. And so I'm very common on my smartphone, and then I'll have to go, and I want to be able to move. And you'd think that'd be a very simple scenario, but it doesn't work. It's riddled full of problems, and we'll talk a little bit more about that. So those are the 2 scenarios. So what we did to kind of prove this out after we kind of looked this analytically and said, okay, well, what are the issues? How do we tweak this? How do we control it? We actually went in our buildings. We live in building 30 and 31, the Lync group. And we actually retrofitted the buildings. They were designed, I think, at 11G kind of networks. They didn't have APs all in the right spots to blanket it everywhere. And to cover those two scenarios, we retrofitted the buildings. And we spent the money upgrading the buildings. And each building has about 600 Lync users. Now, these are the actual Lync group. This is building 31 is all the Lync developers, all the Lync, like our teams, and all the Lync kind of groups and part of the Lync division. And so we have very critical developers and who are very critical about what they want from the experience. And so we intentionally put that, we call it dog food, which most industry call a trial. We put that in the buildings to see what the reaction would be. And what we did was we deployed 182 APs. They were deployed about 60 feet apart. And we put them about, in every corridor, every meeting room. So we just blanketed everywhere. So there was no place you would have brownouts or blackouts in anywhere of the buildings. Everything was done correctly. And also, we spent 2 years of tweaking. And I'll show you the guidance that we got out of that. And we took that guidance and that deployment, and now I like to say that we're rolling across those two buildings across the whole world. And the reason is, with our Surface that got announced, and we see the BYOD, people wanted to use, more and more Wi-Fi and run Lync on Wi-Fi. So we retrofitted all the buildings in the Puget Sound and moving across the world to this profile, which I'm going to show you in a second, and what we did here in the dog food. So very successful program, we think. We're very happy, very grateful to Aruba helping us through this. I want to talk a little bit about the QoS guidance. We see this all the time, that people don't turn on QoS. Lync needs to be enabled with QoS, and as you'll see from the API diagnostics, a lot of times, in fact, when we were diagnosing problems where people were complaining about voice not working right, we'd find that the markings weren't correct, it wasn't enabled correctly in the infrastructure, it would be stripped off, remarked. Oh my God, it was riddled full of problems. And trying to keep the infrastructure up to date correctly with QoS and not being drifting is a very big challenge. And so having the ability to understand what's going on and to correct it, like what we talked about with what Aruba is doing with the API, is very powerful. These are the markings we recommend. Of course, enterprise can use any PHB, behavior markings they want, but this is what we recommend to use. So voice in the EFQ, video in the AFQ, and so on. So this is kind of like the heart of what we learned. We deployed 8 to 11 135 APs, and hopefully in the future that'll be ACs, and basically, we also obviously enabled enterprise mode for WPA2, but a couple of key points here is we enabled obviously radio management, all that kind of stuff. But what's really different in a voice video world on Wi-Fi than data is you have to have the signal and noise ratios correctly. So what you could get away with data and bursting and be bursting and retransmits and all that can't happen in voice and video, because retransmissions don't mean anything to us. The frame's already arrived. If you're going to send us another frame, it's out of order. We're just going to chuck it anyway. So retransmissions have no bearing to us. So the idea is you have to have very good signal to noise ratios of power levels, and you need to have good receive signal quality. And so what was good enough for a data world will not work in a voice video world. So this is something that people have to get used to, is that you have to design your network for voice and video in mind. So you have to have it, if you want mobility scenarios, you have to make sure it's blanket all across the building so they can move and not get brownouts and blackouts and not get degradation of the performance or quality, because it'll affect the voice and video. And you'll get very, very horrible quality. So this is kind of like the key point. Also, what we're finding with UC is now, before it was like, okay, I had one device, my laptop, that was Wi-Fi. Now with tablets, laptops, and smartphones, people are carrying 3 devices for every user. So we have 90,000 employees are carrying 3 devices. So that adds up a lot over Wi-Fi. And also, so those are key points. So obviously in conference rooms, you need to have multiple APs because, kind of the loads. And then also, the load balancing is all critical. And Aruba has all these great features.
Pascal, the capacity that you were designing for there, is 20 clients a mixed client? So a mixture of laptops and Lync clients?
Yeah, exactly. Yeah. So you're talking about design capacity for 20 clients per radio. That's right. So for each radio, we assume to be 20 devices, right? So not users. Okay. So you divide that by 3. The other thing is we also recommended, obviously, to do band steering. So whenever these devices, these BYD are capable of doing 5 gigahertz, we wanted to make sure we move them off to the 5 gigahertz because, the 2.4 is so crowded. Also, obviously, we want to turn on 40 megahertz channel and get more performance, but not definitely on the 2 gigahertz band. So the other thing is enabling QoS. We talked about that. In Lync, you have to specifically enable QoS. By default, it's not. So you have to enable QoS. And then you have to make sure the thing we've learned is just because you enable QoS on the application layer, it doesn't get to the WMM driver layers because it's up to the operating system that reset dissert code points, and then it has to be translated through the operating system into the WMM tags and make sure they show up correctly. So there has been instances where operating systems weren't doing the right thing, and what you thought was enabled for QoS was not showing up on the Wi-Fi through WMM tags, and that was a big issue to fix and understand and go back to the operating system guy and say, hey, you got a problem here, and try to fix it. So these are the things we learned, for example. The other one is, like I talked about, a lot of remarking happening on the wired side. So even though you would have everything done correctly, you configured all the QoS and the markings on the client of the Lync clients. Then all of a sudden, the infrastructure will remark it back to 0. So,
will there be an interoperability configuration guide published with all the tweaks that should be enabled?
So the great news is when you're Aruba qualified, not only they publish this guide that talks about all this configuration, how to tweak it, how to turn it on, and what to do, which was all things I'm describing. They also publish all their test results. So on that link I showed you, you can go there, you'll link to their website, and you'll see all of that, right, just described. Cool. Yeah. So that's exactly what the qualification program does. It helps customers understand this and how to tweak it and turn it all on. The other thing is we also put in a separate SSID for mobile devices just so they can get power saving by changing the detemp timer. So that actually kind of beneficial for your battery. So that's as we did there too. So let me look at the time. So some lessons learned is that things that are really broken on the BYOD devices, certainly not on the AP side, but on the BYOD devices, there's off-channel scanning. I mean, if you off-channel scan for a second, not a big deal of your data, because that will just, it's bursty. It'll just buffer it and burst it, and no big deal. In voice and video, you have a consistent frames coming. You got packets coming out consistently every 20 milliseconds, and so if you go off channel scan for too long time, you're going to have a problem. We're going to have a problem in the session, and so we were seeing that in some of these these more inexpensive BYOD devices trying to run voice and video over it or Wi-Fi. So this is an issue that's not quite well known. The more problematic issue that's pretty well busted about 90% is this idea that these BYOD devices would be too sticky. They would actually stick to an AP and go down to like minus 90 dBm, right? Then actually go ahead and hand off to something what was like minus 65 or minus, even better. And it was like baffling. And then it would, at the last minute, wake up and realize that it's so bad quality, then it would start panicking to figure out another one, and then finally go off channel scan and figure it out and then hand off. In the meantime, the experience from the user was horrible. And sometimes it would, be like seconds of breakage. So, are you there? Are you there? And so this is unacceptable for us. We don't accept this as a user experience for Lync. So the other one is the rate adaption and the retransmissions. I talked about that. Rate adaption algorithms are all over. Everybody has their own proprietary secret sauce rate adaption. And rate adaption is a problem because we don't care about retransmission. So if you come down just a little bit, to check it out and get a little bit of retransmissions, that's not good for us. We want you to get down to a level fast enough to get no retransmission so we can get things happening, even if it gets at a slow rate, and then slowly bump your way up. But we were finding all different algorithms of how they did rate adoption. And retransmissions for data is fine. Retransmission for voice and video makes no sense to us, and it just kills the airtime. So it's something that needs to be fixed. So what we did was, Aruba and ourselves kind of sponsored this, is we went to 16, 17, now we have 18 vendors, all the silicon guys, Broadcom, Intel, Qualcomm, you name them, all the AP guys, and including Cisco, Aruba. And we worked with a large of these of this ecosystem manufacturers, and we went and we come up with a new proposal, and we're calling this multimedia mobility over Wi-Fi. And this is to solve all the things I talked about in a standards way, so the driver's guide do this correctly, and it's shipped on all the BYOD devices, so we have a great experience. So this is actually going for a vote to the WFA next week. And we think this is going to pass, and we'll start a marketing task group to start building this. So years out from now, maybe a couple of years, I think, we'll actually see all these problems solved. But in the meantime, we have some great innovations from Aruba to try to solve some of this with proprietary ways. So that's basically where our experience has been with the Wi-Fi program. It's been a couple of years in the making. Very thanks to Aruba being our DEP partner, helped us through tremendous of kind of chopping down these big alligators and getting to a point where we have a great kind of story. And now people are implementing it. And so they can go to the Aruba website, they can see they're qualified, they can get all the how to deploy, what knobs to turn, and feel very confident. Obviously, some of these devices have problems, and we kind of educate them. You have to be careful. And even some of these enterprise-grade laptops have problems. So we found a lot of problems in our lessons, even in driver issues from these enterprise laptops. So I won't name names, but slowly we've been going into them and they've been fixing them. So the Lync Diagnostic program is what Kriti alluded to. Was we came up with this innovative idea was, what if we could actually make Lync and networks play better together? And this is really the SDN model, if you think about it, right? The idea that Lync as an application can communicate to the networks, in this case, Aruba Wi-Fi, and they can do some cool things about it, including tell you what's wrong, is a very, very great lower cost benefit from a lowering TCO, right? And the complexity of trying to deploy all this stuff. So what we did was we realized that our Lync traffic is encrypted, not only in the signaling, but we run everything over secure RTP. So RTP has no well-known ports. It runs UDP, but there's not a well-defined port. It's actually, to get the port, you have to, for that session, you have to go to the payload of the SIP transport to get that, and that's all encrypted. And so everything's encrypted. So very hard for networks to understand what's going on and how to do things right. So, so this was, one of the reasons why we wanted to make this API happen. The other one was people use probes everywhere to kind of, to try to figure out what's going on, and that's just a huge cost from operational and capital. And then finally, this is probably the most problematic issue, is QoS traffic. QoS is really difficult to deploy and expensive. Not only you have to deploy it once, but you have to keep it constantly tuned consistently. And that tuning and keeping it up to date is what we call configuration drift. It was very common in a lot of enterprises and deployments to do that, including internally in Microsoft IT. So this API was designed to kind of help and figure this out and solve some of these issues. So the API was designed not to solve problems within Lync itself in the system, like mic placements of the telephone or the laptop, but they were designed for actually determining what's wrong in the network. So root cause analysis in the network to what's happening in the network, so that can actually help the administrator pinpoint when someone's complaining what's actually going on. So, so that's really the goal of the network, of this program. We developed this API that's a web service API. We call it the Lync Network Diagnostic API. It'll be changing names in the future. I won't say what that is, but you'll be seeing that come out. But for now, the scenarios are on diagnostics. And finally, we talked to a rich set of ecosystem, network ecosystem kind of vendors, Wi-Fi, Aruba being one of them, and you see the demo of some of the scenarios about this. What else do I want to say?
Is this a good
Yeah, if you, yeah, oh yeah, we want to do the time of the demo, yeah.
Since we talked about the diagnostic,
Yeah.
maybe it's a good time.
Yeah, perfect.
Here I've brought up the Aruba controller. So this is the AppRF dashboard, so I can get a feel for which users are using the most traffic and what's going on. So down here I see the Lync desktop sharing, the Lync video, and the Lync voice are the majority of the traffic on this particular network. And again, this is the information coming to us from Microsoft so that we know exactly what's going on, that no guess is being made. I can then also drill into a specific user. So here I'm taking a look at Vader. And I can see the general client health information that we have within the controller, how many packets, how much goodput. If I click over to the Lync tab, I can now see the current information that's running. So I can see what voice calls there was, what video, and what desktop sharing. And so here we've identified the 3 different pieces, which was just mentioned are encrypted parts of that SRTP, but now we have visibility into it. And more importantly, as I scroll over, I can actually see the original WMM and original DSCP mappings, and I can see where we modified them and scaled them up because we had visibility into that flow. And we were able to adjust the voice to one level, video to another, and not affect the desktop sharing so that the data piece didn't have to go too high. Although in this case, we did bring up the desktop sharing a little as well. But I can start to see that information, diagnose it, troubleshoot it, and get visibility into the QoS, kind of end-to-end on my network now through the controller with the integration with Microsoft Lync. Cool. And pass it back.
Thank you. Yeah, I think, you hit it right on. I mean, the idea that you could see that the markings are wrong is awesome. And then more important, that you can correct it is really the advent of kind of like a software-defined network where you're changing things, or so you can change the markings, so that helps a lot. So that, again, automates the deployment of quality of service. So where's the clicker?
Access into the actual audio flow. The whole purpose and reason for being able to encrypt the RTP traffic now is so that we can't use something like Wireshark and break out the audio packet and start, monitoring people's phone calls. We don't have any access into that through that API, correct? So there's no security concerns about all of a sudden having this API open up on a client end and somebody starting to be able to go in there and build the tools to rebuild your audio paths?
No, we don't. We give you rich attributes. The API gives attributes about the session. It doesn't give the actual payload of the session. Okay. Yeah. So basically, the deployment scenarios we see for this API, has to be around on-prem, cloud, hybrid. We don't have just an on-prem world. More and more people are using the cloud, and then hybrid versions of that. And then finally, what's really cool about the API, it's available on Lync 2010 too. It's shipped today out of band, and it's done through our partners. Our only strategic partners have access to this API for their customers and their channels, because we're not just giving it out to anybody. It's very strategic to us, and we will probably change how we deliver that API in the future. But today, like Aruba has this API, has access to the API. They give it to their channels to deploy on their Lync, and we're working through more models on how to get that to distribution to customers. Also, like I said, it deploys in 2010, 2013, which means that you don't have to just have the most up-to-date Lync deployment to do this. And finally, we continue to advance this API. We have had some great discussions about how to advance this for new scenarios around call admission control and other kinds of stuff, where now the actual, for example, a call happens, we check with the network, and is there a capacity? And if there's not, we don't let the call and go busy. Today, there's no way of communicating that way. That's just a hypothetical scenario. And so finally, we've been developing this prototypes. We've been working with Aruba. And then finally, they're about to go into shipment. I don't know if they've talked about the release dates. I'll let them talk about that. And then finally, they're going to meet the qualification program like we did for Wi-Fi. We're going to have a qualification program for this API program. So I think that's the. And I want to say that again, they've been a very depth partner. They're going through extensive testing and trials right now with this API, and you're seeing a demo of that. And finally, the qualification of this should be ready around calendar year Q3, where they'll be shipped to market. So I don't know exact dates, so I'll let you guys talk about that. So, and then finally, if you want more information, there's some information on the Wi-Fi stuff and how to get a hold of me. Okay, thank you.
Thank you very much, Pascal. Appreciate
Okay.
it. That was great, very informative. In terms of dates, Aruba 6.3 will be available. It's in beta right now. If you want to test with it, it's available for you. We're planning to ship it either later this month or early June. Airwave 7.7 is also in beta, and we're going to be shipping that in July, August timeframe. Those are just quick dates for you, and I believe we're going to take a break now, a short break, 5-minute break, and come back with a Q&A after this.